In our previous videos and examples, our equations in two variables have had both an x variable and a y variable. However, we're going to find that there are two specific examples that are exceptions to this rule, and those are lines that represent both vertical and horizontal lines. So a vertical line is given by the equation of the form x equals a, where a is the x-intercept. So you'll notice in the case of a vertical line, there's not a y variable involved. It is just x equals a, so a constant. Now, when we are graphing and we see x equals a, it's actually easy to graph this kind of line because we automatically recognize, oh, that's just a vertical line, and that vertical line is going to occur wherever a is. So in this case, a is 3, so the graph of the equation x equals 3 is just going to be a vertical line at x equals 3. Let's try that again and see if we can get that a little straighter. So we're just going to go to where our x value is 3, and we are going to draw a vertical line. Now, another way of thinking about it, if you want to find points, you can think about it that what does this tell us? It tells us that x is 3. So if we create our table over here and we choose values for y, well, if y is 0, what's x? X is 3. And if y is -4, what's x? X is 3. And if y is 1,000, what's x? X is still 3. So we could find solutions to this equation if we wanted to, but what it ultimately comes down to is that x is always going to be 3 regardless of what our y value is. Now, on the flip side of that, we have a horizontal line, and for a horizontal line, its equation is always given in the form of y equals b, where b is the y-intercept. So up here it was x equals a, and a was the x-intercept. For a horizontal line, it's y equals b, so y is the only variable that we're using, and b is the y-intercept. So looking at our example, we want to graph the equation y minus 2 equals 4. Now notice it doesn't look exactly like y equals b, but what I do notice about it is that it does not contain an x variable. So that tells me that I'm working with a horizontal line because it only has the y variable. And in order to graph it, all I have to do is to get it in this form. So I need to add 2 to both sides so that I get y by itself. And then I will be able to graph the equation. So I get y is equal to 6. The fact that it's y equals 6 tells me it's horizontal, and it's going to be a horizontal line at y equals 6. So I count up to where y is equal to 6. So 1, 2, 3, 4, 5, 6. And I graph a horizontal line at y equals 6. And again, if we wanted to choose a table of values or create a table of values, we could. In this case, we would randomly choose the x values. So if x is 0, what's y? Y is 6. If x is -1, what's y? Y is 6. And if x is -526, what's y? Y is still going to be 6. So we can see that all of those points are in fact going to fall on the line, the horizontal line at y equals 6. Now remember from previous, there's something special about the slopes of vertical and horizontal lines as well. For a vertical line, the slope will always be undefined, because if you think about the definition of a slope, it's the change in y over the change in x. But if we look at our vertical line, what's true about x? Well, the x value doesn't change. So since the x value doesn't change, you'll end up with a change in x of 0, which makes the slope undefined. For a horizontal line, it's change in y over change in x. Well, it's the y value that doesn't change. So you end up with a 0 on top, which always produces a slope of 0. So you know you're working with a vertical line anytime that you have x equals a constant, or you can get it in that form, or you have an undefined slope. And you know you're working with a horizontal line anytime that you have y equals b, or can write the equation in that form, or you have a slope of 0.